We're seeing a push for lighter, stronger, and more reliable components across small arms and defense programs. Which materials or processes, whether glass-filled polymers, tungsten MIM, or high-temp plastics, do you think will define the next decade?
We've basically built our company around introducing lighter weight, higher performance materials into our clients' hands. And one of the things we do to make sure that we're doing the right job for our clients is to stay abreast of all of those materials as they come out. I mean, I'm going back to the 70s and the 80s when my dad first was working with Allied Signal. It had a new material called polycarbonate. And they knew it was good, they knew it was strong, they just didn't really know what it was going to be used for. So we were beta site for them. They were right over here in Morristown, and they would come over here and we would trial things. So being on that forefront, I think is very, very important. And getting that seat at the table, so to speak, early on is an advantage for us because we get to really know the material, how to process it. There are a lot of nuances to processing some of these high temp materials. So if you don't process it correctly, what a lot of people don't really understand is it's not only that we put the material in the mold and we squirt it into the injection mold tool and then you get the part out. If you don't process it correctly, you're not going to get all of the high performance properties and characteristics that you spec'd out the material for in the first place. A great example would be if you don't dry it properly, if you don't hit the right moisture level, you will not get the performance that you're looking for. Similarly, if you don't design the gate appropriately on the tool, you'll get shear. So maybe you've got a great 50% VLF or very long fiber polymer material, but if you don't have all of those polymer fibers in the right location of the part, or they're not oriented properly, again, you haven't really done what you're supposed to do as far as using that material the way it was designed to be. So at PTI, having all of those people here that understand what's happening on a molecular level inside that mold is really critical to making sure that that material does what it's lives up to all of it that it was capable of doing. As the other part of your question about metal replacement, that's really how we started our company. Was there were as an aerospace vendor, you're always looking to cut weight and you're always looking to cut costs. So, but you can't compromise on performance. So finding that good enough solution. A polymer or molecule of polymers is never going to be stronger than a polymer of metal, but what is that good enough solution? What is going to get the mission done? And you're reducing costs and you're reducing weight, and those go hand in hand with aerospace. Finding that balance and offering up those solutions to customers is something I think we do pretty well.